So in this video, what we're going to do is talk about common student errors when proving properties of matrices. In the homework, you'll need to prove one of the matrix properties, and on the next exam, for sure, you'll have to do it then as well. And so what we want to do is identify the most common student errors that I see when students are doing these types of proofs. So here, this says prove property 1. So property 1 was that matrix addition is commutative. The order in which we add matrices doesn't matter. So a common student error would be to do something like this, to give me a couple concrete matrices. It'd say, hey, let A equal 1, 2, 1, 1, and let B equal, let's do another matrix, 0, 1, 2, 1. And then they'll do something like this. They'll go, here's the matrix 1, 2, 1, 1, plus, here's the matrix 0, 2, 1, 1, 1, and then they'll add them. So we get 1 plus 0 is 1, 2 plus 1 is 3, 1 plus 2 is 3, and 1 plus 1 is 2. And because they're trying to show that matrix addition is commutative, they just did A plus B. Now the student will do B plus A. They'll go B plus A. So they're going to do 0, 1, 2, 1 plus 1, 1, 2, 1 equals 0 plus 1 is 1, 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 1 is 2. And then they eyeball these two matrices and they say, yeah, look, the addition commuted. I got the same result regardless the order I added them in. And then it's not uncommon for me to be handed a homework assignment where a proof is done and this is exactly what it looks like. So there's multiple things that are wrong with this. So 1, this isn't wrapped in any sort of natural language. The student isn't using English words to explain to me what's going on here. So there's no language wrapped around the mathematics. That's one thing that's wrong. There's two matrices that are the same, but no written conclusion has been drawn. No conclusion is drawn. The student is leaving it for me to guess what the conclusion is based on the work that they've done without telling me what they're concluding. 3, this is a concrete example. So this example doesn't prove that matrix addition is commutative. This would demonstrate or prove that these two matrices are commutative under the operation of addition. But there are infinitely many matrices that can be constructed, and if they're the same size, they can be added to each other. So when we do a proof, we never show a concrete example. Never show a concrete example, because this only is a proof for this specific example, but we need to show that it's true for all matrices that exist that are of the same size, right? We can add two matrices when they have the same size. We need to show that that matrix addition is commutative for all of them. So in the next video, we'll take this same property and we'll prove it, but we'll prove it generically for all matrices, and we'll wrap things in language. We'll draw a conclusion, and we won't use a concrete example. We'll do it generically so that it applies to all matrices.